Today we will
Good
start
morning.
with chapter. Good morning. Today we'll start with chapter 9, lesson 1, which talking about quadratic graphs and their properties. We will learn how can we graph the quadratic functions of the form of y equal ax squared and y equal ax squared plus c. Now, before talking about graphing, let's now differentiate what is the difference, or let's see what is the difference between the function, the expression, and the equation. In chapter 7 and 8, we talked about the expressions. Like if I told you 3x squared minus 2x plus 4. If it's like this, I called it an expression. Now, if I add y equal 3x squared minus 2x plus 4, or I add f of x equal 3x squared minus 2x plus 4, this now is a function. If now I have the expression and I say that this expression is equal to 5, it comes like equation. Then I want like to find the answer of x. Like 2 plus x equal 5. This is an equation. Here also this is an equation. So 2 plus 6 only is an expression. So 2 plus 6 only is an expression. But f of x equal 2 plus x or y equal 2 plus x is also is a function. But 2 plus x equal 5 is an equation. This is now the difference between equation, function, and expression. Look at the function, the graph here. The blue paper, that is f of x equal x squared minus 6x plus 5 is the function. The green one, x squared minus 6x plus 5 is an expression. The yellow one, that x squared minus 6x plus 5 equals 0 is an equation. Today now we will learn how can we graph the function.
Miss, I have a question.
Yes, Huda.
This one, fx equal 2 plus x.
Yes, this one you mean. Okay.
What is it? Yeah.
What's it?
For what we use it, like how we can use it in
This is a
questions.
function. This is a function. This function, if you want to graph it. But I told you what is a function. Inshallah, later on, and you will know today, now we will learn how can we graph it. Later on, you will know how to differentiate it, to integrate it. We told you like f of x equal 2 plus x. So what about f of 4? You will say 2 plus 4. This is a function.
Okay, thank you, Miss.
Okay, Miss, you are welcome. Now, in this lesson, we will talk about quadratic function, not trinomial, not fourth degree, not monomial, only about the quadratic function. What does it mean? That means the higher degree is 2. Like this example here. Like 3x squared. The higher degree is 2. So it's a quadratic function. X squared plus 9 The higher degree here is 2, so it's a quadratic function. Y equal x squared minus x minus 2 is also a quadratic function. If I have y equal x squared, I say it's a quadratic function. But if I say x squared minus x minus 2, this is only, I will say it's a quadratic
expression.
Thank you. Without y, I say it's a quadratic expression. With y, I will say it's a quadratic function. So now we will deal with the quadratic function. All of us know that the standard form of the quadratic function y equal ax squared plus bx plus c. This is the quadratic function, the standard form of the quadratic function that I've found most of you didn't write it correctly in the quiz. You have to start with the higher degree, ending with a constant and simplifying b. Don't let it negative 7x plus 5x. Simplify it to write it in this standard form. So this is now the standard form of the quadratic function. Y equal ax squared plus bx plus c. Now let's talk about drawing or graphing. By now, I told you about functions, the quadratic functions. Now let's talk about graphing. The simplest quadratic function is y equal x squared. This y equal x squared, the simplest one, we call it a quadratic parent function. Y equal x squared is a quadratic parent function. This is the parent of the function. How can now we graph it? All of us know that for the linear function like 3x minus 5 or plus 5 as an example, how can we draw the linear function? Plotting the points, after that you will find that it makes like a line. If you connect the points, you graph a line. That's why we call them linear, because its graph is line. What about the quadratic? Here, because it's to the power raised to the power 1, it is linear, its graph is line. Now what about the quadratic? For the quadratic, it's not a line. It's like U-shape, or we called it parabola. So to graph the quadratic function, it's like the U-shape, the parabola. Later on, when you talk, inshallah, maybe in grade 9, when we talk about the cubic, it's a graph like this. So for the quadratic, it's U-shape, or we called it parabola. For the linear shape, it is line. For the quadratic, it is what? U-shape. So the graph of the quadratic function is U-shaped curve. We called it parabola. This is like this example here. This is the U-shape that's present y equal x squared. Later on, we will know how can we graph it. But this is now this shape for y equal x squared for the parent of the parent function. So the shape of the quadratic function is a parabola, or we said it is a U-shaped. Now look at this one here. Look at the line from this point to this point. You'll see that it's the same length from this point to this point. And here also. And here. and here. You mean like if you have this U shape and you have this line here. If you look at this purple line here, sorry, pink line here, does it cut the U shape into two equal halves?
Yes.
Yes, miss.
So,
Yes, teacher.
so this line that's divide the parabola into two matching halves, I called it axis of symmetry. Axis of symmetry. What does it mean? That means this is the y-axis, as you see here. This is the y-axis that's cut the parabola into two equal halves that they make the first half are symmetric with the second half. We called it axis of symmetry. Okay, but please, I want to give you 1 minute and I will. So the axis or the line that divides the parabola into two matching halves, we called it axis of symmetry. Now, here we have the x, y axis. If the shape is this U shape, it's like this, I will say that the axis of symmetry is the y axis. Is it right? The axis, this is the axis. That's cut the shape into two equal halves is the y axis. So the axis of symmetry here is what? Is the y axis. So the axis of symmetry here is what? The y axis. Now, imagine now that we have, this is the xy plane also, and this is the y shape here now. This is the parabola also. It is the y shape. What is the axis of symmetry here? Is it the x-axis or the y-axis?
The x-axis.
The x-axis. Thank you. So here it is the x-axis. Why? Because this is the x-axis. Mute your microphone.
تسليم يوم ما جاي ان شاء الله بخير الله يسلمك.
جنى.
كم حصلتي؟
جنى. Mute your microphone.
It is not Jana.
Who's saying? Who's saying?
Teacher, there is a girl, but it's not Jana. Yes, maybe. Don't know. But it's not Jana.
No, because the name that's appearing here is Jana. That's why I say Jana. Okay. So in the green parabola here, the axis of symmetry is the y-axis. But in the pink, the axis that's cut the shape here into two equal halves is the x-axis. Now, sometimes, this only we will talk about it on this chapter. This one later on. But I want to tell you this, this is like extra information. If you have this line of axis as an example, and this is the parabola, it's drawn here. Okay, so here now it will not be an axis of symmetry. The line that's cut it, I will name it with line of symmetry. So if the line of symmetry is on the x-axis or the y-axis, I will say it is an axis of symmetry. Is it clear?
Miss, I didn't understand the blue one.
This is an extra information. It's not any here. Just tell you that this is the parabola. If the line It is the line. If the line cut the parabola into two equal halves, I will call it line of symmetry. If the line is on the x-axis or on the y-axis, I will say it is axis of symmetry. This is not so important. I want you just to look at, for 1 minute, look at the pink circle. Look at this line, this parabola. If it is it could be upward or downward. This is for this our chapter. And the axis of symmetry here is the y-axis.
Okay, Miss, thank you.
Sorry?
I said thank you, Miss.
Okay, you're welcome. Do you have any question now?
No, Miss.
The one with the
No,
blue,
teacher.
the blue parabola, it's also the y-axis?
No, here you will say that it is at x equals x equal 4 as an example. Later on you will talk them.
Okay.
At this point as an example, it is 4. You will say at x equal 4.
Okay, thank you, teacher.
You are welcome. This is not so important. I want you just to know the axis of symmetry. So by now we talked that the parabola, the shape of the parabola is U-shaped. We called it the shape of the quadratic function is U-shaped. We called it a parabola. And the axis that cut the parabola into two equal halves, we called it an axis of symmetry. Now, as you see now, so by now we said that this is the x-axis. This is the y-axis. And the shape, like this is the, sorry. This is now the U-shaped for the parabola. Now, for this one here, as you see, this blue line, we say that it is the axis of symmetry. Now, this shape is the parabola. Now, this point, the lowest point on the parabola, we called it a vertex. The lowest point on the parabola is a vertex. Now, sometimes it's like this. This is a U-shaped and this is a U-shaped. In both cases, this is the line of symmetry. Or sorry, the axis of symmetry. Where's the? This is, let's change the color first. This is the axis of symmetry. Now, so both of them are U-shaped. We have an axis of symmetry. Now, the lowest point on the pink U-shaped or on the pink parabola is a vertex. And this point, the highest point on this U-shaped also is a vertex. So a vertex is the highest or the lowest point of the parabola. Now, when the vertex is the highest point and when the vertex is the lowest point, look here. Look at this one here, this function here, y equal ax squared plus bx plus c. Look at it. Look at this one here. Ax squared plus bx plus c. Now, since now a is positive, like 3x squared, I told you, 4x squared. If a is positive, okay, the parabola opens upward like this one here. So this one, it's like for 3x squared as an example. Here, it is for y equal 3x squared. When the a is positive, what is a? A is a number that is multiplied by x squared. If a is a positive, so the parabola open upward, as you see. And since the parabola open upwards, so the vertex is the minimum point or the lowest point of the parabola. So if the y is positive, the parabola open upward, and we have a minimum of the vertex point is the lowest point. How we can say, let's write it with L. UL. Positive A, upward, and you have at the lowest point. Now, if y for this function, y equal ax squared plus bx plus c, like y equal negative 2x squared. If the a now is negative, the parabola open downward. If it is negative, the parabola open downward, and the vertex is the maximum point or the highest point. That's mean in the positive or in the in the positive a, when it is open upward, like you start with a small point and this point is becoming greater. But in the negative a, you start with highest point and it become lower. It will be in decreased. So that's here we said if the a is negative, the parabola open downward, and we have a maximum point, or the vertex is a maximum point. But if it is positive a, the parabola open upward, and the vertex is the lowest point. So I will draw them here like this. Positive a, it's open upward, so we have the vertex here at the lowest point. If it is the u gone downward, that's mean the a is negative, and the vertex here is the highest point. Is it clear?
Yes, teacher.
Teacher,
It's
I'm
clear.
kind
Yes,
of
miss.
confused at this one.
We want to find now the coordinates of the vertex of each graph. Then after that, I want you to tell me if it is minimum or maximum point. Let's do it here. Look at number A now. At A, what is the coordinates of the vertex? Before that, it is gone downward. So what is the sign of A? Because
Negative.
it is downward.
Negative.
Yes, it's negative. So it is downward. So we have negative A. Thank you. Now, what is the coordinates of the vertex? So what I have to say? I have to say like vertex, open, two brackets. Now, what is the coordinates here? Look here.
0, 3.
Negative.
Now look here. This is each cube is 1. So this is 1, 2. Here is 3.
3.
So I will say 0, 3. Is it right?
But Yes, and the negative sign.
What's negative?
Where I will put the sign of A, the negative.
No. Here just for the function.
Okay.
I want only now the points or the coordinates of the vertex. Now, is it minimum or maximum?
Minimum. لا, maximum.
Maximum.
It is at the highest point of the parabola. So it is maximum. Now, look at B now. Where's the vertex? The vertex is it here. It is the lowest point. So, what is the coordinate of the vertex now?
1 and -1.
1, -1.
Thank
1,
you.
-1.
-1. Is it minimum or maximum?
Minimum.
Minimum. Because it is the lowest point of the graph, so it is minimum. Let's do another example to get clear for you. Let's have this one here now. Look at this one here. Where's the vertex of the graph?
Negative. No.
Is it here? Is it right? Here is the vertex.
-3.
Where's the vertex? Is it here? Or here?
No.
Or it is
No.
at the lowest point.
Yeah, the lowest point.
Okay. So let's now name the graph, name the vertex. Let's make like this, okay? To name them. I will remind you. First, name the axis point, the x-axis point, which is -2, and the y-axis point, which is negative.
-3.
So the coordinate of the vertex here is negative.
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 2 and
Now,
-3.
is it minimum or maximum?
Minimum.
Minimum. Thank you.
I didn't understand how we know if it's minimum or maximum.
Look at here. This point, is it in the minimum? Is it in the lowest point?
Yes.
Since it is at the lowest point, so I will say it is minimum.
Okay.
If it is
Teacher, the lowest point would be negative.
the highest point, I will say it is maximum.
Okay, thank you, teacher.
Okay, you're welcome. Now, you can use the fact that the parabola is symmetric to graph it quickly. Since now the parabola is symmetric around the x-axis, so we can use this symmetry or this fact to graph it. So by now we learn what is the vertex, what is the line, how can we find the vertex, how can we find the axis of symmetry, what is the shape of the quadratic function, and what is the quadratic function. Now let's see now how can we graph it. You can use it by, first, you have to find the coordinates of the vertex and several points on one side of the vertex. First, you have to find the vertex, then the coordinates of the vertex of the several points and not the vertex, another point. Then reflect the points across the axis of symmetry. Let's have this example here. Graphing y equal ax squared. Graph the function y equal third x squared. Make a table of values and what are the domain and range. Now, all of you, please concentrate with me, focus with me, and look here. The function now is y equal third x squared. Y equal third x squared. Now, a, is it positive or negative? The number that the coefficient of x squared, it is positive. Is it right? So that's a hint for me that it is gonna to be upward. This is the first thing. Now let's graph it. The first thing you have to put like this. Make a table for x and y axis. Our x point and y points. Start with 0. 3, 6, and 9. Choose any point you want. But you must start with 0. Y. Now, at x equal, now, what we have to do? And then after that, we say that x is 0. Is it right?
Yes.
If x is 0, I want you now to evaluate x with 0. So let's clear x now and put instead of x here
0.
now. I will say that it is third x squared. So y is third, and instead now of x, I want you to evaluate with x squared. So instead of x, I want you now to put a point 0. So 0 squared, 0 times 1 over 3,
0.
0. So the y here is 0. Now, let's try point number 3. Now, clear this 0 and point 3 now instead of x. Then I will say now 3 squared is 9. 9 times
It will be
9
3.
times 1 over 3, like mean 9 divided by 3. 9 divided by 3 is what?
3.
So the point here is 3, 3. Now, I want now to evaluate point number 6. So let's now remove this x and put now number 6. 6 squared.
12. No, 36.
36.
36.
Times 1 over 3.
Equal 12.
36 over 3 is 12.
12. 12.
It's 12. Now, let's now put a number, I don't want number 9. Let's choose, wait, please. Let's remove this x. Let's put it here. Remove this x. This.
Did you know the value of x?
How do you know the value of x? How? Yeah.
Yeah, teacher, because you're in the question that there is no value for the x.
These numbers 0, 1, 3, 6. You put it from your mind. Put any numbers you want.
Well,
Okay, I choose 0, 1, 3, and 6.
okay.
Now let's evaluate point number 1. So here the function that I plot any points Then I evaluate the points in the function to find the y. Now 1 squared is 1 times 1 over 3 is 1 over 3. So by now I have now 4 points. 0, 0, 1 and 1 over 3, 3, 3, and 6, 12. Okay?
Okay, teacher.
So I have now these 3 points. 0, 0, 1 third, 3, 3, and 6, 12. Then now let's plot all the points here. 0, 0. This is now the first point. And then 1. Now here we have point 1, 2, 3, 4, and 5. This is 1, 2, 3, 4, 5, 6, 7, 8, and 9. And here we have 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. Now let's start with point 0, 0. Here is 0, 0. Now 1 and third. So the point. So now the second point, 1 third, is here. Now then, 3, 3. Where's the point 3, 3? 3, 3. So it is here. Now then, 6, 12. So it is where it's going to be upward. Here is 6, 12. It's going to be upward. Example, let's make it here. Then, so I put now positive numbers. I put now the vertex. The vertex is as point 0. So I find the vertex. I found now any several points on them. After that, connects now between these 2 points, between these points. Let's connect them now like this. Then after that, since the y-axis is the y of symmetry and it cuts the shape into 2 equal halves, what does it mean? That means this is a mirror. If this is like this, make a reflection here to continue the second part. By now, we draw now the function. Is it clear?
Yes, teacher, but why I made the reflection? And when I draw only from one side.
Mom, I told you that the shape of the graph of the quadratic function is U-shaped. Okay, but you draw it like this. Is this a U-shaped?
No.
I told you from at the beginning that since now A is positive, so the graph, it will be upward, U-shaped upward. So after you finish this, connecting these or the plotting these points, connecting them, you will find that the shape is not U. They told me that if you want to draw the quadratic function, first you put the vertex, plot the points, connect between them. After that, make a reflection. Why I draw this reflection? Because since this axis is axis of symmetry, it's make like a mirror. So imagine that you have this half here. If you reflect it, you will make this shape. Connecting them, you will make a U shape.
Okay.
Okay. Then the second step now, find the domain and the range. How can we find the domain and the range now? Did you know what is the domain and the range?
Teacher, I remember that domain like the X and the range is like the Y.
Excellent. The domain, that's all the X values, and the range, that's all the Y values. Now, this is the domain. Look at me now. Where's the domain? This is the domain. Now, look at the domain here. Is there any problem that is there any point that I have a problem with it?
No.
Or I can use any
No.
real number.
I can use
any real numbers. Is it right?
yes.
Yes.
Here so. So now this, if I choose 0.1 or 3 or 6 or 12 or -7 or -100, there's no problem. So the values of this X here, okay, if I choose any point, there's no problem with me. So because of that, I will say now the domain is all real numbers. So this is now for the domain. It's all real numbers. Now what about the range? The range is all the y-axis. To find or to know the range, you have to look at my graph here. Look at the graph. Is there any graph on the negative y-axis?
No. Yes,
No.
yes. The origin.
The negative y-axis.
No.
No, it's only in the positive y-axis. So the values of y, as you see from here, it starts from 0 up to infinity. It starts from 0
Up to infinity.
Okay? Up to
Okay.
infinity.
So
These all now the range. So because of that now, the range,
all natural numbers.
no, you will say now the range. Look at me. Open this. Now, how can we write the range now? To write the range, look here, you have to use this point because this 0 is included. Hello, you say it starts from 0 until positive infinity. You start from 0 upward, from 0 to infinity. Now, at infinity, you must put this type of bracket. And at 0, you must put this closed one. This closed one, that means the 0 is included.
Okay.
Okay, inshallah, Sunday, I will give you more examples and I will continue. You can understand it. Just please rewatch the video to summarize, to repeat your the lesson today.
Okay, miss. Thank you so much.